Hello students, again I'm very happy to see you through this third video. I think you might have gone through the two previous videos and you might have understood what I have taught. See, in the first video I have given an introduction how you can able to get electrostatics from electromagnetic waves. The second one we have studied about the charges, the positive as well as the negative charges, and I have explained how Benjamin Franklin can able to get the positive charges and the negative charges. So we have also seen a concept that like charges repel and unlike charges attract each other. Today what we are going to see? Today the topic that we are going to see is the behavior of electrical charges. Today we are going to study about the behavior of electrical charges. So how we can able to study about the behavior of electrical charges? See, if you want to study about the behavior of electrical charges, first of all we have to know about its properties. So the first point that we are going to study today is the properties of electrical charges. When you are considering about the properties of electrical charges, we are having some three properties given in our book. Generally there are four properties. One more property I am explaining you just to see. We will see about four properties. What are that four properties that we have to study about the electrical charge? The four properties are: number one, the first property is generally called to be an electric charge. What about the second property? The second property is taken to be conservation of electrical charge. Second property is conservation of electrical charge. What do you mean by this conservation of electrical charge? Let us see. What is the third property? Third property is generally called to be quantization of electrical charges. Quantization of electrical charges. And the fourth property of the electrical charges is its additive nature. Its additive nature. These four are generally called to be the properties of electrical charges. Let us see one by one. What is the first property? The first property is generally called to be electric charge. So what do you mean by this electric charge? Let us take like this. You consider any material or you consider any object. If you are considering any material or any object, that material or that objects are made up of what? They are made up of atoms. When you are considering this building blocks of the materials or the objects as atoms, the atoms are made up of what? These atoms are made up of positively charged nucleus and negatively charged electrons. Positively charged nucleus and negatively charged electrons. If you are considering this positively charged nucleus consists of positively charged protons and chargeless neutrons. When you are considering these neutrons are considered to be chargeless. So the building blocks of the materials are atoms, or we can say the materials or the objects are made up of atoms. Atoms are made up of nucleus as well as what? Nucleus as well as negatively charged electrons. And when you are considering about the nucleus are made up of protons and chargeless neutrons. Now, the What is the inherent property of the electron? What about the inherent property of the atoms? What about the inherent property of all objects? See, we can say that inherent means the hidden or the basic. The inherent property of all objects. Here, generally considering this as all objects is taken to be mass. The inherent property of all objects or all materials is taken to be mass. Each and every object in this universe is having its own mass. And there is another intrinsic fundamental property. See, what is the another intrinsic fundamental property? The another intrinsic means inward. Another intrinsic fundamental property. Another intrinsic fundamental property that is available is taken to be property is nothing but the electrical charge. The another inherent property of the objects is taken to be electrical charge. What is the fundamental electrical charge? What is the fundamental electrical charge? What we are considering is the fundamental electrical charge. The fundamental electrical charge is taken to be basic electronic charge. Is considered to be basic electronic charge. It is generally represented by either Q or by E. Then how it is measured? It is measured by an unit, or I can say the SI unit of the electrical charge. SI unit of electrical charge is considered to be coulomb and represented as C. Clear? So, what is meant by electrical charge? Most of the objects in this universe, or most of the materials in this universe are made up of atoms, or we can say atoms are the building blocks of the materials. When you are considering an atom is made up of positively charged nucleus and negatively charged electrons. When positively charged nucleus is considered, positively charged nucleus consists of positively charged protons and chargeless neutrons. First concept. The second point available is here. The inherent property of all objects or materials available in this universe is its mass. And there is another basic, or we can say fundamental inherent property. That another basic fundamental inherent property is considered to be electrical charge. Generally, it is represented by the letter small q, and or we can say it as E. It is called to be basic electronic charge, charge of one electron. And then it is measured, or SI unit of this charge is considered to be coulomb, represented by the letter or represented by the letter C. This is considered to be the first property. Let us go for the property number 2. What do you mean by this property number 2? Property number 2 is conservation of charges. What do you mean by this conservation? Conservation of electrical charges or conservation of charge. Generally, let us consider, what do you mean by this conservation? Nothing but constant. You might have studied about law of conservation of energy. That energy can neither be created nor be destroyed, but it can be transformed from one form to another form in an equal amount. Similarly, I can able to state the law of conservation of electrical charge. How the law of electrical charge, conservation of electrical charge can be defined? Let us define it out. You see, we know that law of conservation of electrical charge is like this. Charges can neither be created nor be destroyed, but the charges can be transformed from one material to another. We can say in equal amount. So this is considered to be conservation of electrical charge. So I am repeating, the conservation of electrical charge is defined as charges or electrical charges can neither be created nor be destroyed, but it can be transformed from one material to another material by some means that let us see later. This is one law, conservation of electrical charges. The same law can also be stated in another form. How it can be stated in another form? I can state like this. See, total charges, another total electrical charges in an isolated system. In an isolated system is always a constant. Is always what? Is always a constant. This is what we are considering it as another form of what? We can take like this. It is considered to be another definition or another form of conservation of electrical charges. Okay, clear? So I can say I have given you two definitions for the conservation of electrical charges. For example, the first one, charges can neither be created nor be destroyed, but it can be transformed from one form to another or from one material to another. The second one, see, the total electrical charge in an isolated system is always a constant. See, or we can say in any physical process, the net change in charge is zero, or the net change in charge is always zero. See, we can write like this. Also, we can write. See, in any physical process, the net change. See, in any physical process, the net change available. The net change is always what? The net change is always zero. So I am repeating the third term. In any physical process, the net change is always zero. See, according to Benjamin Franklin, the charges can get transferred from one material to another material while it is rubbed. I have already told that the number of charges available in both the materials, that is the rod as well as in the cloth, both are considered to be same. So we can say, according to Benjamin Franklin also, the transfer of electrical charges is taking place from one substance to another substance while rubbing. The two substances are having equal amount of charges. So this was proved by Benjamin Franklin. This was proved by whom? This was proved by Benjamin Franklin. Okay. See, moreover, I can state so many other examples also. What are the other examples? I can consider an atom. See, when you are considering an atom taken to be uranium having a mass number as 238 and atomic number considered to be 2092. If it is a radioactive substance, so if it is emitting an alpha particle, then the element relieved is alpha particle, means it is nothing but a helium ion. So a new particle will be formed. That new particle will have the atomic number as 90, and when you are considering about the mass number will be 234. If it is 90, then this is thorium. This radioactive material which is getting converted into thorium when it emits an alpha particle. The emitted alpha particle is nothing but what? Is nothing but helium ion or helium nucleus. See here, the conservation of electrical charges taking place. You see, in case of uranium, there are 92 electrons or 92 protons. See, charge of one electron is E. That is the basic charge. So, total number of charges available is 92 or 92E. Here you see, in case of thorium, I am having 90 as its atomic number, which states that 90 electrons or 90 protons are said to be available. Charge of one electron is considered to be E. There are 90 electrons, so total charge available in this thorium is 90E. You just consider helium, there are atomic number is 2, so 2 protons are available or 2 electrons are available. So I can say basic charge of electron is E. Since there is having 2 electrons, I am having 2E. This is before disintegration. These two considered to be after disintegration. So, before disintegration, the total charge is 92E is equal to, after disintegration, the total charge available is 90E plus 2E. I can able to get it out as what? I can able to get it out as 92E. So, the total charge before disintegration and total charge after disintegration are considered to be same or equal. So, you see, in any physical change or in any physical process, the net change is always what? The net change is always 0. So, the change, total change is considered to be 0. Before disintegration also you are having the total amount of charges is 92E, and after disintegration also the total amount of charges available is 92E. This can be taken as one example. We can also go for the next example, which was being given by Benjamin Franklin. What Benjamin Franklin stated? Benjamin Franklin stated that when you are considering about the glass rod, when the glass rod rubbed with silk cloth, what will happen? This glass rod acquires positive charges and equal number of negative charges are available in the silk cloth. This was the example given in your book. So from this, what is the conclusion arrived? Due to rubbing, so conclusion arrived is due to rubbing, there is a transference of electrical charges. There is a transference of electrical charges so that the rod considered to get positive charge and equal amount of, and we can say equal amount of negative charges are available in the silk cloth. Similarly, I can consider the next one. What is the next example that we have studied? I can consider an ebonite rod, or I can consider a rubber rod, or we can consider a plastic rod. Either ebonite, rubber or plastic when it is rubbed with wool, or you consider fur. On rubbing, what will happen? The ebonite rod acquires negative charges and equal amount of the wool or fur, that is the flannel or the cloth, acquires positive charges. In this case, ebonite rod or rubber rod or the plastic rod acquires what? Acquires negative charge, and wool or fur acquires what? Wool or fur acquires positive charge. So from these examples, we can able to say there is no creation of electrical charges. So from this we are clear. What is the clear idea? Charges are neither created, charges are neither created nor destroyed. But what happened? there is only a transference of electrical charge, but only charges are said to be transferred. Only charges are transferred. So this we are calling it out as the second property called to be conservation of electrical charge. So we can summarize. Basically, charges can neither be created nor be destroyed. There is only a transformation of electrical charges from one body to another. Or we can state it in another way. The total charges in an isolated system is always a constant. Then the third one, in any physical process, the change in electrical charge is always equal to zero. So I have given you three definitions for the conservation of electrical charges. And for example, I have given an example with the help of uranium and thorium atom, which is not given in your book, but it is very, very important. Uranium having an atomic number 92, mass number considered to be 238. When that radioactive substance is emitting an alpha particle, then you will be able to get helium nucleus as the alpha particle emitted out. Helium nucleus having atomic number 2, mass number 4. So what is the remaining element? The remaining element is thorium with atomic number 90. Now before disintegration, total charges available is 92E. E is considered to be charge of 1 electron. 92 electrons are available in uranium. After disintegration, we are having two elements. One is thorium, another one is helium. When you are considering thorium, thorium is having 90 electrons. Charge of 1 electron is E, so 90E. When you are considering helium, there are 2 electrons. Charge of 1 electron is E, so 2E. Add out, you will be able to get 90E plus 2E, 92E. So before disintegration, the total charge is 92E. After disintegration, the total charge is again 92E. So we can say there is, in that physical process or in that chemical process, there is no change in the electrical charges. I think you will be very clear. See, we can also prove this with the help of the example that is given in your book. According to Benjamin Franklin, already in my previous class, I have told you, when a glass rod rubbed with the silk cloth, then the glass rod acquires positive charge and equal amount of negative charges are available with the silk cloth. Then the next one, when you are considering an ebonite rod or a rubber rod or a plastic rod rubbed with fur or wool, then the rubber rod or plastic rod or ebonite rod is negatively charged, while the cloth called to be fur or wool is considered to be positively charged. So from this, we are very clear that charges can neither be created nor be destroyed, but there is only a transference of electrical charges from one material to another material by a physical process. Here the example that was being given, is having the physical process called to be rubbing. I think you will be very clear about this idea, a 3-mark question in your examination, for your examination. Okay, let us move on to the next one. What is the next one? The next one that we have to go is quantization of electrical charges. So the third one, and what I am going to state is quantization of electrical charges. What do you mean by this quantization of electrical charges? What do you mean by quantized? Quantized means well defined. Well, when you are considering that, now we are being quartined, that is, we are being isolated like that. When you are considering the electrical charges are well defined. That is, we can say like this, the smallest or the fundamental basic electrical charge is charge of an electron. So I can consider like this, the basic or the fundamental electrical charge that is available is charge of an electron. Charge of an electron which in any material, the basic electrical charge available is charge of an electron, generally represented by the letter E, and its magnitude is 1.602 into 10 to the power of minus 19 coulomb. This is the basic charge or the value of one electronic charge. See, in your book, simply they have given it out as 1.6 into 10 to the power of minus 19 coulomb, rounded off to 2 digits. Okay, the basic electronic charge, the charge of an electron, or you can also say this as charge of an proton. Charge of an electron or charge of a proton is considered to be equal to 1.6 into 10 to the power of minus 19 coulomb. So if you are considering any object, that object is having a basic electrical charge or basic electronic charge E, and the value of that electronic charge is charge of an electron, which is 1.6 into 10 to the power of minus 19 coulomb. Now let us consider a charged body. When you are considering a charged body, the charged body is represented by the letter Q. How much amount of charge is available in this charged body? So it was quantized like this. The total charge available in this body is always equal to integral multiple of the basic charge. Integral multiple of the basic charge. It is mathematically written as Q is equal to N into E. What is that N? N is an integer. N may take the value as plus or minus 1, plus or minus 2, or plus or minus 3, or plus or minus 4, etc. What do you mean by this? The total charge available in any charged body is taken to be either it may be equal to plus 1e, or plus 2e, or plus 3e, or plus 4e, etc., or minus 1e, or minus 2e, or minus 3e, or minus 4e, like that. Never be 1.5e or 2e, never be in fractions, 1e, 2e, 3e, like that, it won't be available. So the materials, any charged body or any charged material will have the charges in such a way that they are in integral multiples of the basic charge or basic electronic charge. So the basic electronic charge is E. It is in integral multiples. That is basically written mathematically as like this. How it was written as Q is equal to N into E. You can expect a problem from this, a 2-mark problem from this. How many number of basic charges or how many number of electrons are available in a charged body? Like that you can able to get a problem. Let us see the problem later on. Okay, what is the next? And this part we are calling it out as quantization of electrical charges. See, we have seen an example before. That is, when a glass rod is rubbed with the silk, there will be 10 to the power of 10 electrons are transferred. Generally, when you are considering, when a glass rod, see, when you are considering a glass rod, when it is rubbed with what? When it is rubbed with the silk cloth, the number of electrons transferred from glass rod to silk cloth is considered to be in the order of 10 to the power of 10. So, in this case, the charge quantization is not appreciable at macroscopic level. See, quantization of electrical charges cannot be applied to a large amount. That is, it cannot be applied in macroscopic level. It will be applied only in microscopic level. But the microscopic level alone, we are having the quantization of electrical charges playing a vital role. You just consider the final concept alone. You leave this, you just consider. See, when you are considering the quantization of electrical charges, that is, Q is equal to N into E. This quantization of electrical charges, let us consider in two forms, one in macroscopic and another in microscopic level. See, macroscopic level and microscopic level. The quantization of electrical charges very well applicable only in microscopic level and not in macroscopic level. Clear? Again I am repeating it. The third property that we have studied is quantization of electrical charges. The basic or the fundamental electrical charge available in any body or in any material or in any object is the charge of an electron, called to be basic electronic charge, represented as E, having a magnitude as 1.6 into 10 to the power of minus 19 coulomb. That is also equal to charge of one proton. When you are considering the total charge available in a charged body, which is represented as Q, the total charge in the charged body is equal to integral multiples of the basic electronic charge. So the integral multiples, that is written mathematically as Q equal to N into E. That N represents the integral multiple. So N is the integer. N assumes the value as plus or minus 1, plus or minus 2, plus or minus 3, like that. That is, a charged body can have the charges in the order of plus 1e, plus 2e, plus 3e, plus 4e, or minus 1e, minus 2e, minus 3e, minus 4e, etc. It cannot be in fractions. That is the concept. And when you are rubbing a glass rod with a silk cloth, the number of electrons transferred will be in the order of 10 to the power of 10 electrons. Why I am saying this means, when you are considering the quantization of electrical charges can be considered in two levels. One is macroscopic level and another one is microscopic level. But quantization of electrical charge is very well applied, or it is applicable in microscopic level and not in macroscopic level. And we are not bothering about the macroscopic level, and we will be considering only the microscopic level. This is considered to be the third property. These are the three properties that are being given in your book. But there is a fourth property also, and the fourth property is taken to be additive nature of electrical charges. Additive nature of electrical charges. What do you mean by additive nature of electrical charges? See, what do you mean by this additive nature of electrical charges? I can explain you with the help of an example. I am considering two charged bodies. See, for example, I am taking one charged body having a charge considered to be plus 5e. I am having another charged body having a charge considered to be minus 3e. When I am adding or when I am combining these two charged bodies into a single charged body, then the resultant is taken to be plus 2e. That is, I have considered what? I have considered the algebraic sum of the two charges. Algebraic sum of the two charged bodies. Two charged bodies. Any number of charged bodies you can consider. Here I have considered only two. So algebraic sum means the add paniko minus the subtract paniko. That's all. That is called to be the algebraic sum. See here plus 5. You see plus 5 minus 3e. Plus 5e minus 3e. The resultant is 2e. I can state another example. You just consider like this. I am having the first charged body as minus 5e and the second charged body is plus 3e. When I am combining, what is the result? The result is minus 2e, because minus 5e plus 3e, the resultant algebraic sum, just add it out, you will be getting it as minus 2e. Or I can take like this, one of the charge to be plus 3e, another charge to be plus 2e. If I am adding, the resultant is plus 5e, or minus 3e, and another body having a value as minus 2e, add it out, you will be able to get minus 5e. So the resultant is, or What is the conclusion is? If you are having two or more borders and if the charges are combined, the resultant is equal to algebraic sum of the individual electrical charges. Are you clear? This is called to be additive nature of electrical charges. So I can state that definition: net charge. Okay, I can state that